Hello everyone, and welcome back to our channel. I'm Shakur. Today we are tackling a classic problem in mechanics of material involving a rigid bar AD supported by two steel wires and a pin at D. Now, here's the catch. This is a statically indeterminate system. That means the equilibrium equation alone aren't enough to solve it. We'll need to look at the geometry of deformation to find the tension in each wire. Let's dive in and see how it's done. Problem 2.46. The rigid bar AD is supported by two zero wires of 1 16-inch diameter, E equal 29 multiplied by 10 to the power of 6 psi, and a pin and bracket at D. Knowing that the wires were initially taut, determine A, the additional tension in each wire when a 120-pound load P is applied at B, and B, the corresponding deflection of point B. Here we need two equations to solve this question. One of them according to geometry of deflection, and another one according to another main formula we have, which is equal deflection equal load multiplied by length divided by area and E. But first, let's go to free body diagram and write the equilibrium equation. Here we have this figure and the structure. Let's draw the force. Here we have F, let me check, FCF, and also here we have FAAE. Let's write the moment about point D. We have sigma m about D. We have positive equals 0. It means minus 24 FAE or PAE. F equal P. PAE plus 16 P, that's P we have here, minus 8 P CF equals 0. It means for P we have 24 PAE plus 8 PCF divided by 16. We need PAE and PCF, and we use this formula for achieve P. It means here we have P, it's equal deflection multiplied area and E divided by length. And here for PAE we have E A and deflection of A or AE divided by LAE, which is equal, E is equal to, here we have equal 29 multiplied by 10 to the power of 6 psi. and L is equal 15 for AE, and for FC is equal 8. And also for deflection we have another equation. I write it here. According to geometry of deflection, here we have a little deflection, and this is deflection of A, and here we have deflection of B, also deflection of C, and here we have theta, which every part of them it's equal 8, I think. Yes, 8 inch. 8, 8, and 8. We know that tan theta, let's write this red. Tan theta is equal sine theta divided by cosine theta, which theta is so little. We have theta because cosine is equal 1 and sine theta is equal theta. Theta equal, here we have deflection of A divided by 24. It means deflection A is equal 24 theta. And also for deflection of B and C we have theta equal deflection of B divided by 16. It means deflection of B equals 16 theta, and the deflection for deflection of C we have deflection C divided by 8. It means deflection C equal 8 theta. We use theta, make it correct. Theta. We use these three equations in our formula, and that means we have E, which is equal 29 multiplied by 10 to the power of 6. And area, which is equal P divided by 4 multiplied 1/16 to the power of 2. We have it here and say its diameter. And also we have 24 theta instead of deflection of A here, and LAE it's equal 15. That means PAE equal 142.353 multiplied by 10 to the power of 3 theta. Now let's write the similar equation for PCF. Here we have PCF equal EA, which these two parameters is similar to PAE. EA and deflection of C dependent of theta divided by LCF. We have 29 multiplied 10 to the power of 6 multiplied by P divided by 4, 1/16 inch to the power of 2 and 8 theta divided by 8 PCF equal 88.971 multiplied by 10 to the power of 3 theta. Now we have this equation. And we should achieve P dependent of theta. According to this equation, we have also P here, and now we want to achieve theta from this equation or that one. Let's write it here, one of them. For example, we have minus 24 PAE plus 16 P minus 8 PCF equals 0. Now we have PCE, P and PAE. That means minus 24 multiplied by PAE, which is equal 142.353 multiplied to 10 to the power of theta. And also P and PCF, and we write it here 142.353 10 to the power of 3 theta plus 16 multiplied by 120 and minus 16 minus 8 multiplied by 88.971 multiplied 10 to the power of 3 theta equal 0. Here, if we solve this equation, theta equal 0.4651 multiplied by 10 to the power of minus 3 radian. And now time to achieve PAE and PCF. P is equal, PAE is equal 142.353 multiplied by 10 power of 3 theta, which is 0.4651 minus 3. It's equal approximately 66.2 pound. And for PCF, also we have 88.971 multiplied 10 to the power of 3 theta, which is theta is equal 0.4651 multiplied 10 to the power of minus 3. And also PCF is equal 41.4 pound. And for B, we need deflection of point B, which deflection of point B is equal 16 theta. And here we have deflection of point B equal 16 theta. It means 16 multiplied by 0.4651 the power of minus 3 equal 7.44 multiplied 10 to the power of minus 3, which is like this. And we have a sign here. That's it. I hope you find it useful.